Good morning. Welcome to the YouTube channel. Now, the unit number 2 solid state drives, concept name control strategy of DC chopper. Already we have studied in power electronics what we have studied control strategy of a DC drive. How can we make and control in DC drive, that we have already studied. Anyway, we are going to go through the points once again. The output voltage of chopper. Here the output voltage of chopper can be controlled. How? By varying the alpha value, that is duty cycle. By varying the duty cycle, we are making the control of a DC drive. How can we make the DC duty cycle in this chopper? We are having two types of control strategy. One is time ratio control, that in common name we'll call it as T or C, time ratio control. And in second control we are having current limit control, that is CLC. Sometimes in university exam they may ask this short form also, TRC, that is time ratio control, and CLC for the 2 mark questions. So we need to consider both the thing equally. What is time ratio control? Time ratio control in the sense the value of alpha, we know time ratio control T or C, the value of alpha which is equal to what is T on divided by T, that is our duty cycle, that is the ratio time, on time in total time. In total time, how much time the switches is on, that is ratio of T on and to T2, T, where duty cycle is called as like that. So here how many times we are making a switches into turned on and how many times the switches is turned off for a single time, that we need to consider. So we are making that kind of control strategy. So T or C can be furtherly classified into constant frequency control. What do you mean frequency control? Constant frequency control. And another one is variable frequency control. You can see control, constant frequency control and variable frequency control. What is first of all frequency? Frequency is nothing but F is equal to 1 divided by T, that is ratio of time, that is called frequency. Now we are going to give the 1 by 1 method of constant frequency control and variable frequency control. What do you mean constant frequency control? We are making one set of control first, one set of control, and while we are comparing this one set of control with another set of control, if in these two set of controls how many time the switches has the total time, that is on time plus off time, same will be obtained here, that is in total time. Here T1 we call it as T2, T1 is equal to T2, that is in our constant frequency control. We'll draw one diagram. For example, we are having one voltage, supply voltage is obtained in output voltage. So we are having one graph. The graph should contains x-axis time, y-axis supply voltage, starts from 0. Initially we are making one on, the switches is getting turned on, and after some time the switches is getting up to this time, switches is getting turned off. So from this graph I will draw one more blue pen. See here the switches is getting turned on up to this time, after that the switches is turned off, and again the switches is getting turned on for some time, and the same switches is getting turned off. That is our T on and this is our T off. I already told you this is one set of control. Here the total time, we will call it as the total time T. So T is a total time. We go for next set of control. In next set of control I am going to draw the same graph. X-axis as T, y-axis as Vs, starts from 0. Here we should not change the total time. This is one set of control, and another set of control we should not change the total time. So we draw the total time is as it is. We should not change the total time. So T1 and T2. Then how can we change the how can we make the difference between these two control? We can change the on time or off time. Anyway, it will be changed. For example, if we have less on time and more on time, so comparing, in this type of firing there is a control, and this type of firing there is a different controls, but in these two different control we are maintaining the frequency as constant by maintaining the time as constant. If the time is constant, obviously frequency is constant, so it is called as constant frequency control. I'll repeat it. In constant frequency control we are having two set of controls, that is control number 1 and control number 2. In these two set of controls, the width of the pulse is varied by maintaining the time as constant. That is, either or on time or off time is alone getting varied. On time or off time alone is anyone, both should vary. Since the pulse width is varied with a method called as pulse width modulation, that we already know. The constant frequency control gives the ripple and require smaller size of filter. By using this we can have smaller size of filter. That is very important. This constant frequency control we have only smaller size of filter and also fast response. Both can be obtained. Smaller size of filter is alone required and faster response. This is the proper DC drive. That is our constant frequency control. Now we can see variable frequency control. Variable frequency control in the sense, first we are making one set of control. And next we are having another set of control. If these two controls is not equal, in the sense that will be, if it is not equal in the sense, that is called as variable. Here one set of time is preferred, that is T1. Here one set of time is preferred, that is T2. If T1 is not equal to T2 in the sense, obviously F1 is not equal to F2. That means we are obtaining variable frequency control. We are having first one set of control, and that control we are using one set of frequency, and in second we are going for next control. For that we are using second set of frequency. If these two frequencies not matched in the sense, obviously we can say that is variable frequency control mode. How can we classify this variable frequency control mode? In the sense, we are going to change the frequency. We are changing the total time. So we have the chance we can maintain at any one time as constant, that is T on time constant or off time constant. We are having two set of control here. T on time, that is T on kept constant, that is one type of control. We'll see that, don't worry. And second, off time, that is T off kept constant. So we are having two set of control. First we can see on time control. On time in the sense T on should be constant, kept constant. How can we make this kind of set of control? Initially we, as usual, we are going to draw an y-axis and x-axis. X-axis should be T, y-axis should be supply voltage starts from 0. Initially we are making one set of control, that is we are having one set of control, one on time and one off time, and one on time and one off time. Anyway, this on time should be equal with this on time, this off time should be equal with this off time, because in one set of control, in the sense all should be equal. Here we are having one type of time t1, that is time value t1. Here the frequency is nothing but 1 divided by f, that is if you are taking f is equal to 1 divided by t1 f1, that is the frequency in first set of control. Now we are going for second set of control. Very simple. In second set of control, what should be maintained? That is on time should be kept constant. One set of control is over, so on time should be kept constant. On time in the sense we should not change the on time value. On time is as it is, that is our on time. And off time, obviously we are having the variable frequency. If you are comparing these two times, t on should not be equal, t1 and t2 should not be equal, in the sense we can have another on off time. So this is our t2. While we are comparing t1 and t2, here t1 this much time, t2 here this much time. See, t1 is not equal to t2, so f2 is equal to 1 divided by t2. From these two conditions we can have f1 is not equal to f2. So which that we can say the variable frequency can be obtained by maintaining on time, that is t on kept constant. So remaining this on time in the sense same width should be drawn here. So same width, so it comes here. So I have to draw like this, no need to go. The width alone we need to take, that is PWM method. So t on as it is, and t of this much width alone we are maintaining, so t of like this. Likewise it is going on continuously. So from this graph we could identify that t on is kept constant. In second graph, second thing, here we are maintaining t off kept constant, that is we are going to maintain t off, that is on off time as constant one in two set of control. So that I am going to draw the same graph, y-axis and x-axis. X-axis should be t and y-axis should be, yes, starts from 0. So I am going to draw a rough graph for on time. This is my on time, and another we are having another off time. So this is on time and this is off time. So on time same and off time is also same. T on, T off. So likewise it is going on. So in next set of control we have to maintain t off, that is off time should be constant. So for that I am going to draw off time as constant 1 starts from 0. So on time as it is we can draw that, sorry, off time should be kept constant. So off time this is, so we need to change the on time, then only here t1, here t2 will be, this t1 should not be equal to t2, that's why variable frequency control the heading. So frequency should not be equal, in the sense here we need to maintain off as constant. So off time is as it is, this width. On time alone we need to change. For example, we can reduce the on time, reduce or increase, whatever we want we can do. Reduce, I am reducing here. On time is getting reduced, off time as it is, as it is, the width should be here. So off time, then remaining on time, then off time. Off time width should not be changed, then only it is a constant on off time. But here we are having one set of t1, here we are having one set of t2. This t1 is not equal to t2 here. If t1 is not equal to t2, in the sense obviously f1 is not equal to f2. That means we are not having a constant frequency here. The constant frequency is not maintained in these two set of frequency control methodology. So by using this we can have variable frequency control method. The variable frequency control method, and another name is frequency modulation scheme. Another name is frequency modulation scheme. We can call it as frequency modulation scheme. And the chopping frequency has to vary over a wide range. We can change the going for wide range changes, and the filter design is very difficult here comparing with previous one. In wave frequency method, filter design is very difficult. Frequency method, filter design is very difficult. Here, and the second thing, this type of control would generate some harmonics present. Some harmonics also be present by using this type of control methodology. And the large off time, here we are having some large off time we can maintain. May makes the load current, if you are making off time is very large, comparing with this we can making very large off time. In the sense, load should reaches discontinuity of supply. Sometimes we know already, we have studied discontinuity of supply will be happened. So this is what the entire arrangement, and what actually the variable frequency method has drawbacks. So next we can see the control method by using current limit control. Current limit control, CLC. What is current limit control? Current limit in the sense, load experiences some amount of input current. Input current based on our on time and off time, it will vary, because based on, if you are on the switch, the source is connected with the load. If you off the switch, automatically source will be disconnected from the load. So if you on the switch, the current from minimum value to maximum value it reaches. If you are off the switch, current reaches maximum value to minimum value. So if you are maintaining on time for some value, in the sense we can fix the maximum amount of current. Similarly, if you are fixed more off time, we can reduce the off time into maximum Imax, that is maximum current, into some other value. So based on time, the current starts to increase from minimum value to maximum value gradually. If you are reducing the on time, obviously this may be the maximum time, or this may be the maximum time, or this may be any point. It should not go for the previous one. That is called maximum current, and this is called minimum current. If you are having higher amount of off time, in the sense current reaches to 0 and starts to increase, then reaches to 0. Likewise it is going on. So we can fix based on time and off time, we can fix how much maximum current and how much minimum current that we can make into action. So now I am going to draw a graph for current limit control. Going to draw an y-axis and x-axis. X-axis should be time and y-axis should be a armature current. So first I am going to starts from 0. I am going to have an on time for some value. On time means we can have one kind of control, and off time. Then on time, off time. Likewise it is going on. So if you go for current value for this on time and off time, similarly, that is Vs, current value. So starts from 0, current value starts from 0, and while on time is there, so this much amount of current should be increases. After that, this is my off time, so current once again return back and starts to increase and return back. So this may be a maximum current which experiences in the load, and this may be the minimum current experiences in the load. So I max and I minimum both will be depending upon T on and T off. If I increase the off time to maximum, I will be getting less amount of minimum current and less amount of maximum current. If I increase the on time, I will have maximum amount of maximum current and minimum amount of minimum current. So this is what the CLC, current limit control, can be obtained in our unit. This chopper switches on and off, that is the current in the load maintained between two limits, that is maximum and minimum. So in these two limits can be varied by using on time and off time. So we have studied current control strategy of a chopper. Control strategy in the sense we can have two type of control strategy. One is based on time, another one is based on current. Based on time in the sense constant and variable. In variable we have furthermore classification: on time kept constant variable frequency, off time kept constant variable frequency. And in current limit control we have on time maximum current and minimum current by can be maintained by maintaining T on and T off. This is what the entire concept. Maximum, this question may be asked for 8 marks in university exams, so study thoroughly. Thank you so much.